In today's class, we want to talk about the topic of angles of elevation and depression. Angles of elevation and depression. Note, in our diagram, we have an example of what it means of angles of elevation and depression. Note that the angle of elevation or the angle of depression is measured from a horizontal line. It is measured from a horizontal line. So here we have the horizontal lines, and from these two lines we measure the angles of elevation or depression. Now, anytime we look standing at the bottom and looking up, we're talking about the elevation. When we hear about to elevate, it means to go up. And depression, like the word sounds, just as the word sounds, it means to look down or to go down. So when we're talking about angles of elevation, is that we're measuring the angle from the bottom looking upward. We're measuring the angle from the bottom looking upward at an object. So the angle between the ground, this horizontal line, and the angle we're looking up, this is known as the angle of elevation. The angle of depression is if we are at the top of an object and we are looking down. If we're at the top of an object and we are looking down. So here is the angle of depression. Now, because these two lines are horizontal and a transversal cuts them, right? This line here that cuts two horizontal lines or two parallel lines, that line is called a transversal. When that happens, a Z angle is formed. A Z angle is formed, or what is known as alternate angles. When a Z angle is formed, it means that these two angles are equal to each other. So the angle of elevation and the angle of depression is equal to each other. Now, once we know the angles of elevation and the angles of depression, we could use this information to calculate certain things and to solve problems. Now, let's take an example. Let's take a question and work it out to show how angles of elevation and angles of depression are used to calculate the distance between points or the height of an object. Take this question down. This question says, from a point 80 meters, from the base of a tower, the angle of elevation to the top of the tower is 28 degrees. How tall is the tower? How tall is the tower? So here we have, it's saying that the angle of elevation to the top of a tower, from a point to the top of a tower, is 28 degrees. Now, from that point to the base of the tower is a distance of 80 meters. And we want to calculate the height of the tower, Note that when we have these angles of depression and angles of elevation and we have to calculate, what good thing to do is to draw the diagram. Draw the diagram to show the angles of elevation and the angles of depression. So let us draw the diagram with the information. All right? I hope you would have copied your question from along the bottom of your screen to help you to have the information there. So it says the angle of elevation, angle of elevation is equal to 28 degrees. And the distance from the base of the tower to the point is 8 meters. Distance equal 80 meters. All right? So let us draw our diagram. Now we have the tower. Let's draw our tower first. And we have a point somewhere 80 meters away from the base of the tower. So this is our tower, and our point is 80 meters away. This point, let's call this point A. All right, 80 meters away from the base of the tower. So this is the base of the tower. All right, and the distance between here is 80 meters. Now it says the angle of elevation to the top of the tower is 28 degrees. So this is the top of our tower. Let's call this T. So the tower is TB. So the angle of elevation is 28 degrees. So the angle of elevation is 28 degrees. We know the base of the tower is 80, or the point from point A to the base of the tower is 80 meters. How can we find the height of the tower? We want to find the height of the tower TB. Now, notice that here we have a right angle triangle. And when given a right angle triangle and we need to find one side of the right angle triangle, when we have an angle and the length of one side, we can use our trig ratios, sine, cos, or tan. So we need to know which one we have to use. Shall we use sine, shall we use cos, or shall we use tan? Now let's see what is given. We're given the angle here. And 80 is adjacent. 80 is adjacent to our angle. And we need to find the side opposite the angle. So which trigonometric ratio deals with an adjacent and the opposite? The adjacent and the opposite. Now, yes, that is correct if you say that. Tan ratio. And if you could remember the tan ratio, it says tan A is equal to the opposite over the adjacent. The opposite over the adjacent. So here we have the opposite, which is equal to TB is the opposite, and the adjacent is BA. So what we could do, and the angle is A. So what we can now do is fill in the information. So tan 28 is equal to the opposite, which we need, TB, over the adjacent, which is 80. Now, to calculate that, we can transpose. So TB is equal to 80 multiplied by tan 28 is equal to TB. Now, get your calculators out, and you're going to work that to see what answer you get. 80 times tan TB will give you what? What you could do is pause your video, work it out to see what answer you will get. So 80 multiplied by tan 28 will give us approximately 42.54 meters. So the height of this tower is approximately 42.54 meters, and we calculate the angle, or we calculate the height of the tower from knowing the angle of the elevation to the top of the tower and the distance from a point to the base of the tower. All right, so in our next video we will do some more exercises on this. All right, our next example says a 100-foot building casts a 300-foot shadow from the sun. What is the angle of the pressure? What is the angle of the pressure? So again, what we must do is first we draw our diagram. Let's draw our diagram first. Now, we said we have 100-foot building. So here we have our building, 100 feet high, and it casts a shadow, and the shadow is 300 feet long. So this is our building, right? Let's call our building AB. And our shadow, this is BC. This is our shadow. So our building, 100 feet. Shadow, 300 feet. All right? And what we want to do is calculate the angle of elevation. Angle of elevation. So let's first of all draw. No, we have to calculate the angle of depression. So our angle of depression. Remember we said the angle of depression is measured from this horizontal line. This is the angle we need. All right? This is the angle we need. This is our angle of depression. But as we remember, we also said that the angle of depression is equal to the angle of elevation. This angle here is equal to our angle here, our angle of elevation. So therefore, once we can find this angle, it will be the same for our angle of depression. Once we find our angle of elevation, that will be equal to our angle of depression. So what do we have? We have again a rectangle triangle, we have the opposite, and we have the adjacent. And once we have the opposite and the adjacent, we know we have to use which ratio? Yes, that's our tangent ratio, our tan ratio. Now, what you can do if you think you can solve this problem is pause the video, work it, and when you're finished, play and see if you get the same answer as we would. All right, now you have done that. Let's check our answer. Now, since we're using tan theta is equal to the opposite over the adjacent. And the opposite in this case will be AB, and the adjacent will be BC. All right? So tan theta is equal to the opposite, which is 100, over the adjacent, which is 300. All right? So we need to find the tan inverse of this. The angle will be equal to tan inverse of 100 over 300. All right? So work that and see what answer we will get. So the tan inverse of 100 over 300 will give us approximately 18.43 degrees. 18.43 degrees. So the angle of elevation is 18.43 degrees. Therefore, the angle of elevation is equal to the angle of depression. So the angle of depression will also be 18.43 degrees. All right, and there we have our answer. So let's look at our next question. And again, if you think you could draw that diagram and work that question, please pause the video and go ahead and do it. All right, it says a cliff is 100 meters above sea level, and the angle of depression to a boat is 35 degrees. How far is the boat from the base of the cliff? How far is the boat from the base of the cliff? Again, let's begin by drawing our diagram. So we have a cliff. We have our cliff. Our cliff and of 100 meters, and the boat, a boat somewhere across here on an angle of depression of 35 degrees. So first let's draw our line of sight. Now I used the term just now, the line of sight. The line of sight means that it's the distance that the person is looking from here to here. So the hypotenuse will form the line of sight. This distance, this length from this point where I'm looking at to the boat is my line of sight. The distance from A to C, that is my line of sight. So we have this boat, and then the cliff. Let's call the cliff AC. Right? The cliff is 100 meters. This is our boat, and it says the angle of depression is 35 degrees. Our angle of depression. So we have here is 35 degrees. Now, remember, our angle of depression is equal to our angle of elevation. So if here is 35, we'll have here being 35 degrees too. And now we have to find the distance from the boat to the base of the cliff. The distance from the boat to the base of the cliff. So we have what trig ratio will we use to find that? We have opposite, and we need to find the adjacent. We have opposite, and we need to find the adjacent. So we know that the trig ratio we'll have to use is tan. Tan. So tan 35 is equal to the opposite, which is 100, over the adjacent, which is AB, which is what we need. So to find AB, we have to transpose this. We have to transpose this. So we take our AB over here. So AB times tan 35 is equal to 100. Now, to find AB, AB will be equal to 100 divided by tan 35. So go to your calculators, work that out. 100 divided by tan 35, which will give us approximately 142.81. So the length of the distance of the boat from the cliff is approximately 142.81 meters. And that is how we use angles of elevation and depression to calculate the length. And we want to do 2 more examples in our next session, which will be a little bit more challenging. Alright? So I encourage you to go over this if you didn't understand, and practice it so that you will get better at it.